All right, my friends. So we're going to continue our discussion on working with rational functions. And now the second half of our unit really is now going to focus on solving rational equations. All right. Now to do that, we have to review a couple of skills that are involved with solving. So we're going to work on two things: multiplying, dividing rational expressions, and then next time we're going to work on adding and subtracting rational expressions, because those are skills that are embedded within our solving process. All right. So the good news is, the rules that we're going to follow for rational expressions when we're multiplying and dividing are going to follow what we do for real numbers. All right, and then obviously we're going to have to make a couple of small adjustments because we're dealing with polynomials in the numerator and denominator versus numbers. Okay, so here's what I want you to do. So we have 4 problems here that involve multiplication and division of fractions. All right, so I would like you to pause the video, go ahead and do those, do A, B, C, and D here in the opener. Flip the video back on, and we'll talk about how that connects to what we're going to do with multiplying, dividing rational expressions. All right, so when we multiply fractions, all right, and that's really what a rational expression is, right? It's a ratio of 2 polynomials. We're going to follow the same rules. So when we look at like A here, when we multiply fractions, we do numerator times numerator and then denominator times denominator. So 1 times 3 is 3. 2 times 4 is 8. All right? And then what we typically want to do is think about reducing, right? We then look for a common factor in the numerator and the denominator, and in this case there's not one, so we just leave it like it is. All right? Now, when we look at B, all right, same thing. So we can do negative 5 times 6, which would be negative 30. All right? And then I can do 12 times 8, which would be 96. All right? So we can do that, right? And now we can reduce, right? We can look at numbers that go into 30 and 96, right, and reduce that. So we can say, oh, I can see that 3 goes into the numerator and the denominator, so I could divide both by 3. So that would be negative 10 over 32. All right, and it's like, oh, well, I can reduce again, right? I can say, oh, now they're both even numbers. I can divide both the numerator and the denominator by 2, and I would get to negative 5 over 16. And that would be my final answer. All right. Now, the other thing is sometimes we can reduce before we multiply, right? So some of you might have looked at this and said, oh, 6 divides into 12 2 times like that, right? All right, and 6 divided by 6 is 1. So sometimes you reduce before you multiply, right? And that's a little bit easier, right? Because now notice when I do negative 5 times 1, I get negative 5. And then I do 2 times 8, and I get to that negative 5 over 16, just like we did before. All right, and sometimes the reducing before we multiply is easier because we don't get to such large numbers, right? We don't have to work as hard to find those common factors. Okay, now let's talk about division. All right, so when we divide fractions, we make it a multiplication problem by multiplying by the reciprocal. All right, so we, instead of doing 3/2 divided by 5/4, all right, we do 3/2 times 5/4. All right, so we multiply by the reciprocal. All right, and then it's just the same rules, right? So I can multiply across 3 times 15, or excuse me, 3 times 5 is 15, and then 2 times 4 is 8. All right, okay, so we get to 15/8. And for what we're going to do right now, you can leave it as an improper fraction. All right, if you wanted to reduce that, you could write 1 7/8, but 15 over 8 is stellar. All right, same thing on D here, right? So I would do negative 10/7 times 7/4. Now, once again, here's one of those times where we can reduce before we multiply, right? 7 divided by 7 is 1. And I can divide 10 and 4 by 2. And then I can multiply across. So negative 5 times 1 is negative 5. And then 1 times 2 is 2. And this is really what we're going to do when we do multiplying and dividing rational expressions. It's really much simpler to reduce before we do the multiplication. All right, so that's really a review of how we multiply and divide fractions, all right, which is really like 90% of the problem, all right, when we do multiplying and dividing rational expressions. All right, so now let's talk about some adjustments here. So one, all right, is we do have to factor everything completely, all right, and part of this is 2 reasons, right? One is we have to think about our domain restrictions because we can't have a denominator equal to 0. We don't have to worry about that with fractions, all right? The denominator is not 0 because we have an integer in the denominator. But with polynomials, we can't see that clearly. So we have to factor in order to see those domain restrictions. The other piece is we have to factor because that allows us to see what that GCF could be, right? Or that common factor can be, right? All right, so that's another reason. So there's 2 reasons that we want to factor. So whether we're multiplying or dividing, right? We have to factor completely. We want to state those domain restrictions. What values of x do we have to throw out right away? Now, all right, with dividing, you're going to do that twice. You would throw out whatever makes this denominator 0, and all right, and then when we get to this problem, we have a new denominator here, so we have to throw out whatever makes that new denominator 0 as well. So we have to look at it two ways, okay? All right, so there's a little bit more work when we divide as far as working with that domain restrictions, all right? But then it's really pretty much the same after we do that, right? Multiply the numerators, all right, multiply the denominators, and then we typically just want to leave our answer in factored form. There's no need really to multiply back out, all right, once we have those things set up. All right, so let's take a look at a few problems here, all right, and see what we can do. All right, so let's look at number 1. It is a multiplication problem, and what we want to do is start factoring. Now, I am not going to go through the area model, all right? I'm going to just factor, all right, right away. So if you want to pause the video and then do your factoring model, whatever that is, all right, to get the answers and see if they match mine, I would do that, okay? All right, so just to save a little bit of time, I'm not going to go through the area model with every problem, okay? So now, if we look at the numerator, all right, on the left-hand side, I have a GCF of 3x that I can factor out. So I'm going to take that 3x out, and that's going to leave me x minus 3, like so. All right. Now, when I factor, all right, the denominator here, all right, this is going to factor into x and x, 5 and 1, positive and negative, like so. All right. So now, once again, all right, I'm kind of doing that by looking at the numbers, all right, and looking at the pattern. All right, I've been factoring for like 25 years, so some of these get stuck in my head. All right, so once again, if you need to pause the video, go through whatever process you do for factoring, please do so. All right, now look at the right-hand side, okay? If I factor that numerator, okay, it's going to factor into x and x, 5 and 4, and then this will be a positive, and this will be a negative. And then our denominator on the right-hand side is already completely factored. All right, so right now, we have to look at our denominators and look at the values that make the denominator 0 and throw those out. So as we work through this problem here, if I look at my first factor, notice x cannot be negative 5. That makes that 0, so we have to throw that out. So my domain would be x can't equal to negative 5. Then I go to my next factor here, right? So 1 makes this factor 0, so I have to throw out 1. And then when I come to this factor right here, it's just 0. So I have 3 values that, all right, I want to throw out right away, okay? That means I can use everything else, all right, besides negative 5, 1, and 0. All right, so now let's look for those common factors that we can reduce. And I can see a couple here. So 3 divided by 3 is 1. X divided by x is 1. All right, and then I have an x plus 5 in the right-hand side in the numerator and an x plus 5 in the left-hand denominator. All right, so that's very similar to what we did up here, right, when we had the 6 and the 12, or the 7 and the 7, right? All right, so this x plus 5 divided by x plus 5 is 1. And notice what that leaves me. In my numerator, it leaves me x minus 3 times x minus 4 over, all right, and then the only thing left in my denominator here is this x minus 1, like so. All right, and so that would be our final answer. All right, and notice that you're seeing a lot of the same things that we've done before, right? Okay, with looking for those common factors, checking the domain. All right, so this really is just kind of reusing a lot of the skills that we've already covered. All right, so now let's look at number 2. All right, so now notice number 2, all right, okay, is a division problem. So the first thing we want to do is factor. All right, so x minus 4 in my numerator here. And now when I factor this denominator, it's going to factor into x and x, 4 and 2. This is going to be a plus and this is going to be a minus. And then we're still going to hold on to the division for just one moment, okay? And the reason is, all right, we can't have anything make a denominator 0, all right? So we don't want to forget about doing that before we multiply by the reciprocal. So notice my first factor here, all right, x can't be negative 2. For my second factor, x can't be 4. And then for my third factor, x can't be 5. So once again, I have to throw those values out, okay? Now, we want to multiply by the reciprocal. So x minus 4 over x plus 2 times x minus 4 times x minus 5 over 1. Now notice, all right, we have a new denominator here. Okay, it's a constant value, so that's good because there's nothing else we need to throw out of our domain, because if the denominator is 1, it'll never be 0. And so now I can look for those common factors, all right, and simplify. So notice the only common factors we have is this x minus 4 and this x minus 4 that divide to be 1. So the only thing left in my numerator is x minus 5, and then the only thing left in my denominator would be x plus 2 times 1, which would just be x plus 2. All right, so that is our final answer. All right, let's do a couple more together. So let's flip the page and let's look at 3 and 4. So now when we look at 3 and 4, all right, so what we want to do now, same process, right? So we want to just start by factoring everything. So if I look at my first problem here, now as I factor this, I'm also going to write it in order, right? So notice that the x squared doesn't come first. So I'm just going to, as I factor out, all right, I'm going to factor out a negative 5 here and an x, and that would leave me x minus 1. So I'm just going to rewrite this like that. All right, just to make sure everything lines up, all right, because we typically want it to be in descending order with our powers of x. All right, so then I would factor out a negative 5x, and that would leave me x minus 1. All right, in my denominator, all right, factor this guy. This is going to factor into x and x, 3 and 1, and they're both going to be negative. All right, then times, in my numerator here, when I factor that, it's going to factor into x and x, 3 and 2, negative and a negative. And once again, if I'm factoring too fast for you, all right, you can pause the video, do your factoring, turn it back on. All right, now notice we want to look at our domain restrictions, right? So I'm just going to go through factor by factor. Okay, in my first factor here, x can't be 3. In my second factor here, x can't be 1. And then when I look at my last factor here, which is just an x, all right, x can't be 0. So once again, we have 3 values that we have to throw out. And now we want to start looking for those greatest, or those common factors. All right, so 5 divided by 5 is 1. All right, x divided by x is 1. X minus 1 divided by x minus 1 is 1. X minus 3 divided by x minus 3 is 1. All right, so now we want to look at what's left. All right, so in my numerator, I have this negative 1, so don't forget about that. So I have that negative 1 left, and I have x minus 2 over there. Now notice in our denominator, we don't have anything left. All right, so we just have a 1 there. All right, because everything is divided to be 1. So if you wanted to simplify this one, you could write this as negative x plus 2, or you could leave it like that. And that's really all we have. All right, one more problem, all right, to wrap up this video. So let's look at number 4. So once again, notice now we have a lot of factoring, right? So we see 4 different quadratics there. All right, so let's look at the first one here, and let's factor this first numerator. This is going to be an x and an x and a 6 and a 3, and they're both going to be positive, divided by, all right, it's going to be an x and an x. All right, you got to add to be 6, so I want to be 4 and a 2 plus and a plus. All right, and then divisible, or divided by, and then we want to factor this numerator. It's going to be an x and an x. I need the factors of negative 18 that subtract, all right, or that add to be negative 3, so I need a negative 6 and a positive 3. All right, and then I need x, x here, and here. Factors of negative 8 that add to be 2 would be a positive 4 and a negative 2. All right, so like right now, we have 4 things that we need to consider, all right, in our denominators to set our domain. All right, so if I look at my first factor, right, x can't be negative 4. When I look at my second factor, all right, x can't be negative 2. Notice we get another negative 4 here. That's okay, all right, because we've already accounted for it. And then on my third, or my last factor here, we get a third value. All right, x can't be 2. Now notice, now we need to multiply by the reciprocal, so x plus 6 times x plus 3 over x plus 4 times x plus 2 times the reciprocal, which would be x plus 4 times x minus 2 divided by x minus 6 times x plus 3. All right, so notice now, by multiplying by the reciprocal, we have now created a new denominator. And so we have to throw out the values that make this new denominator 0. All right, so notice when I look at this factor, I can't use 6. And then when I look at this factor, I can't use negative 3. So that's where you get a little bit more complexity when we multiply by the reciprocal. All right, so now we want to start looking for those common factors. All right, so I see an x plus 4 divided by an x plus 4. I see an x plus 3 divided by an x plus 3. All right, and then I have no other common factors, so my numerator, I'm left with two pieces. I have x plus 6 times x minus 2, and in my denominator, I have x plus 2 times x minus 6. All right, my friends, okay, that wraps up our lesson on multiplying and dividing rational expressions. All right, so be sure to do your video check-in, and we'll do adding and subtracting next time.